Hey everyone, Mr. Newman here. We're going to just look at a few word problems and try to identify are these situations discrete or continuous, as well as finding the domain and range. And I'm also going to show you guys how to graph a set of data when I give it to you in a table like this. So first thing you need to do is label your axes. You notice the x-axis is in the first column, so I'm going to put number of serial bars along the bottom there. And since the numbers go from 0 to 6, I'm going to kind of space them out, 0, 2, 4, and 6, like that. And going up the left side here, that's going to be the y-axis. So I'm going to put calories right there. And I'm going to write out 0, and 10, and 20, and 30 up the left side like that, because that's the outputs. All right, now it's time to plot the points. You notice 0, 0, that point's going to go right there. That means when you eat no cereal bars, you're not going to get any calories. That makes sense. That's good. Let's see. 2, 10. The input is 2. The output is 10. Goes right there. 4, 20. That input is 4. So I'm going to put it directly above the 4 and out in the 20. Nice thing is the way I made these scales, it makes them line up very nicely. So 6 and 30 goes right there. Now, there's an important word we need to look at. You see this? You can eat part of a cereal bar. So that means, well, let's see here. Even though it's not in the table, could I eat one cereal bar? Sure I could. If 2 cereal bars gives me 10 calories, 1 cereal bar must give me 5 calories. So I'm going to plot that point right there. Can I eat half of a cereal bar? Well, that's why they told us you can eat part of a cereal bar. So yes, I can eat half of one. And that is right there at halfway between the 5 and the 0. And in fact, I could eat every fraction of cereal bars, right? I could make an infinite number of dots. I could eat a fourth, a tenth, 0.1, 0.0, 0.05. So yeah, instead of drawing a ton of dots, I'm going to connect the dots with a line because that shows that I can eat any part of the cereal bar. So, before we go and answer the question, could I eat more than 6 cereal bars? Well, it doesn't say we couldn't just because it gives us a number of calories consumed in the chart. They say you could eat any fraction of a cereal bar, so I'm assuming you could eat more than that. And you're welcome to ask me that on a test or quiz if you're not sure. So what I'm going to do is I'm going to let this line go on forever. I'm going to draw a little arrow like that. That shows that yes, you can eat more than 6 cereal bars, and those numbers keep on going. Now, is this domain discrete or continuous? Well, the dots are connected, so it is continuous. And the reason for that is because you can eat any part of a cereal bar. So there should be any decimal in between that can be covered. The domain is going to be x is greater than or equal to 0 because you could eat 0 cereal bars, or you could eat any fraction of cereal bars that is greater than 0. You could not eat a negative number of cereal bars, however, so that's why it's greater than or equal to 0. The interval notation way to say that, the range is y is greater than or equal to 0. The reason for this is because you could eat any number of calories greater than 0. But you have to start at 0. You can't eat a negative number of calories here. So the interval notation way to say that is 0 to infinity, where the 0 has the bracket and infinity has the parentheses, and same with the range. All right, let's do the next problem very briefly. You conduct an experiment on the speed of sound waves in dry air at 86 degrees Fahrenheit. You record your data in a table. They really try to throw us off here. Don't worry about that 86 degrees. That doesn't really matter at all. Okay. The data table, let's start with labeling our axes again. So I'm going to label time, t in seconds. Notice seconds are the units, so it's always good to put that in parentheses so that we don't have to write it next to each one. And the distance, d, in miles will be up and down the y-axis because that's on the output side of the table. Let's label 0, 2, 4, 6, and 8 because we have 2, 4, 6, and 8 in the table. And then for the vertical axis, it's a little bit trickier, but you notice it spans from 0 to just under 2. So I'm going to have it go all the way from 0 to 2, and I'm going to use the hash marks as a guideline to mark out mark out decimals that I understand. So 0, 1, and 2. And let's plot the first point. So I'm going to plot this point right about there, 2, 0.434. If you're wondering, wait, how to get exactly there, you might want to go ahead and write down those decimals, so 0.2, 0.4, 0.6, and 0.8, going all the way up to 1. Notice now, so 0.434 is just above the 0.4. For the next point, 4,8.868, that's going to be right about there. You could keep filling in the axes above 1, but I'll just give you the next 2 points, show you about where they are, 6,1.302. And the last pointer from our table is 8,1.736. Now, we have our points. We have to ask, can we have the fractions in between those? Let's start with 0, actually. Could we have 0 seconds? Well, let's see. As this time goes on, okay, the distance gets further away. So at 0, it must have started right on top of it. So I'm going to put a point. This is the you're conducting an experiment of the speed of sound waves. So we're recording the time and distance of sound waves. At 0 seconds, the sound wave isn't going to have gone anywhere. So 0, 0 makes sense as a point. Could we have 1 second? Sure, you could look at 1 second. We don't have that data, but the wave was traveling at 1 second. It was somewhere at 1 second. And same with 3 seconds. And same with half a second. You can have half a second. You can have 3 halves of a second. And so on and so forth. So we need to connect the dots with a line, because anytime, almost anytime, you have time down here on the x-axis, you can have fractions of seconds, decimals of seconds. So we're probably going to be continuous as far as the function goes. Next, can we keep going up and to the right? Well, the sound waves, they keep moving somewhere. So I'm going to go ahead and say, yes, well, that can keep going. So draw a little arrow like that. Now, is this domain discrete or continuous? It's continuous because it's all connected. The domain looks just like the last one. And the range also just looks like the last one as well, because the time can start at 0 seconds and go all the way up, and the distance can start at 0 miles and go all the way up from there. All right. Thank you for watching.